All right, welcome back to the next unit where we're going to be talking about how computers are really, really dumb and what are the limitations of AI workflows. So, most workflows run on a CPU. So, all of these tool calls and the steps are running on a CPU where they're running code after code. So, they run this tool, then this tool, then this tool to kind of give you something. You can kind of branch it out, like if one thing is true, run this thing, or if it's not, run this. But other than that, you have to program that in. It can't basically decide if the file is empty, so I don't do this. So I would kind of like experiment with a thought experiment. So imagine you only were able to look through the world through a peephole, like a very small peephole, right? So the way you would read is you can't read the whole page, so you have to go regular computers are dumb. Like you have to go step by step. So that kind of is what the computer's life is like. So it can only look through the world through a peephole, and that's the instructions you give it. So imagine finding Waldo through a peephole. It's good for linear problems, but if you have to compare things, it's very, very hard. I give this example of trying to play soccer or football based on your loyalties to your country, where you are. Um, if you had one peephole, you would only be able to see your feet. And then in order to see the ball, you would have to move the peephole a lot of times. But if you want to see other players, you would have to move continuously. And you would have to do that a million times or a billion times to kind of like, and you would have to program, like first check where the ball is, check the player is. If the distance between the player is this, then do this, right? So the programming of that, if you were looking through a peephole, would be really, really big. So if you know that people program games, um, in the back end, each player is being tracked by their coordinates in the game, and it's basically checking every 30 times a second whether there's a collision or not. And the way it does is like it looks at their coordinates and sees if there's like a match or not. So it has to keep looking at things all the time. So you have to program everything to the T, and you might have seen like your Chrome crash, and that is probably because it doesn't understand what it's doing and it's in a space where it's not been programmed. So these workflows follow a predefined steps to achieve something because of the nature of CPUs. So you have to account for all the errors, such as like what if like your connection breaks or you run out of credits. You have to program every step, and it can't make stuff up, right? So here's another one where we had an Excel web set. You should try this project of the week course as well, where you take all the companies that raised their Series A in San Francisco, summarize it, creates like a podcast-ish, and sends you an email. And here's the workflow example. Definitely give it a look. But I want to kind of talk about for just the email API, I had to program just for the authentication flow. You have to basically look whether this thing is done, this thing is done. So the conditionals are so much, like you have to just program the whole space out, which might not be very, very useful to certain types of problems, which we'll talk about different types of problems, right? So workflows work well with problems that are predefined, right? Like you can basically trace out all the things that can happen. Like if there's a space, you can be like, oh, this can happen, and I can program that out, right? It's very, very structured. Like if you want to get like your email, what can happen? Authentication goes wrong. So you can put an if else to kind of do that. It's like moving on a monkey bar where you can basically track out what's going to happen. But what if like the ground beneath you is shifting like 100 times a second? Like you cannot predict the space because the things are going to be different all the time. So in the next topic, we're going to go a little bit into understanding these problem spaces and where AI agents succeed really well and what makes a problem very simple to solve. Like they're called deterministic problems, but don't go into the definition. We want to know what a deterministic problem is compared to a non-deterministic problem, which is like there could be many ways to solving it. So I will see you in the next one.